Hello everyone, welcome to the video lecture series on Advanced Separation Process. Myself Jaimin Pandya, Assistant Professor in Chemical Engineering Department of LJIET Institute of Engineering and Technology. So let's continue with the chapter number 2, which is a membrane separation process. In this lecture, we will discuss about synthesis of membrane. So let's start with synthesis of membrane. We know that there are various different methods for manufacturing of membrane, and we already discussed various methods such as a phase inversion process and trackage method in previous session. So let's just revise this method. In phase inversion method, the phase is inverted, or we can say that the phase change during the process. Using this triangle, I explain about the how the phase change going from single phase to two phase system, in which a single phase, which is a solvent plus polymer solution, is transferred to the two phase system where solidification occurs of membrane and liquid solvent that cannot converted in a solid is evaporated using the heat. So it make pores on the membrane. So if we are going to remove this liquid, we will get the pores on a membrane and we get the porous membrane. So discuss about the various method of phase inversion process such as a thermal inversion process and solvent inversion process. In solvent evaporation process, particle and polymer dispersion solution is mixed over and make the emulsion. Then solvent evaporation take place, so we will get the pores and we will get the porous membrane like this. Then discuss about the thermal inversion method, in which we are going to add a polymer solution to the casting roll, and this polymer solution go to this extraction bath where using this roller we can convert this polymer solution into the flat sheet. This flat sheet is go to the drying chamber, and using this drying chamber the polymer sheet will be dry and collected as a roll. So this is all about the thermal inversion process. Next process, which is a trackage method. In trackage method, there is mainly two steps. In first step, there is a one film or polymer sheet is passed through the charged particle. When charged particle is strike on this the membrane sheet, it make pores. So it becomes our step number 1. In step number 1, there is a polymer film where charged particle attack on the sheet and make the pores. Step 2, in which we are going to etch this membrane in each bath. So we will get uniform pore size, or we can create uniform pore size. So this is trackage method. Now let us discuss about another method such as a sol-gel peptization method, interfacial polymerization method, and melt pressing method. So let us first discuss about sol-gel peptization method. From sol-gel peptization method, we can get ceramic membrane. Membrane made of ceramic material are considered better than those organic material because of their better chemical and radiation stability, especially in context of treatment of radioactive effluent. Sol-gel is one of the important route for synthesis of ceramic membrane because of easy of control of membrane characteristic by control of preparation parameter. We can easily control the preparation parameter in this method. So this technique is a comparatively based than other technique for the ceramic membrane. The method of preparing ceramic membrane involve peptization of metal oxide in suitable medium under optimized condition, control of sol viscous by addition of optimum binder, and filtration of viscous sol through the porous membrane, followed by the gelation of layer and sintering. Titanium oxide and zirconium oxide are considered to be a most suitable material for the synthesis of ceramic membrane, and high refractory porous alumina with mean pore size of 5400 nanometer to the pore density of 2.6 multiplied by 10 raised to 6 centimeter are chosen for the support material. This process described in this figure. So, using this figure, we can clearly understand the sol-gel peptidization method, in which first metal oxide are used. These metal oxide are used for the peptidization. In peptidization method, these part particle are converted into the colloid charge particle. So we are going to convert this metal oxide into the colloid particle. Then this colloid particle make a sol using the blinder, and this blinder is passed through the membrane. So in first step, there is a metal oxide we are going to use as a raw material in this process, and this metal oxide is converted into the colloid particle using peptidization method. To converting particle into the colloid particle, this process is known as a peptidization. That's why this process is known as a sol-gel peptidization method. Sol, we are going to make sol using the blinder, and gel, which means gelation process. So we are going to use this both process. That's why this process term as a sol-gel peptidization method. So we are going to make the sol using the blinder. Then this sol is passed through the filtration through microporous support, and gelation process start. Gelation process, which means we are going to make the solid from this colloid particle. So if we are going to freeze the particle, so it's converted into the solid, and we will get this type of solid particle in solution. After gelation process, sintering process will start. In sintering process, we are going to merge this type of particle and convert into the solid. Due to this sintering process, we will get porous membrane layer. So in this method, metal oxide are used. Using hydrolysis or peptidization, we will convert it into the colloid particle. Using this colloid particle, we will going to convert into the solid material using the gelation process. After sintering, we will get the solid particle, or can say that membrane, and this membrane is converted into the dense ceramic. So this is all about the sol-gel peptidization method. Now let us discuss about next important method, which is a interfacial polymerization film process. Tech developed first composite polyamide membrane. This process cast a composite membrane by interfacial polymerization. In this process, with a co-reactant, polymerization takes place at interface, and the formation of polymer prevent further reaction from taking place. Filmtech use amphenyl diamine and trimethylchloride to produce this membrane. The amine is the aqueous phase that is used for the wet membrane, and chloride is the nanoaqueous phase. So this process shown in this figure, where aqueous layer are used and this one is organic layer. At interface of these both solvent, we will get a membrane. Due to the reaction between this aqueous layer and organic layer, we will get a porous membrane. Gap between bond of this membrane, there is a pores, so we will get this pore size due to the gap between bond of this aqueous layer and organic solution. So this is all about the interfacial polymerization process. Now let us discuss about melt pressing process. Melt pressing or melt forming involve sandwich the polymer at high pressure between two heated plates. A pressure of 2000 to 5000 psi is applied for the 0.5 to 5 minutes while holding the plate just above melting point of the polymer. Many polymers do not dissolve in suitable casting solvent. Such polymer, including polyethylene, polypropylene and nylons, can be made into the membrane by melt pressing. Melt pressing or melt forming involve sandwich the polymer at high pressure between two heat plates. A pressure of 2000 to 5000 psi is applied for the 5 minutes or 0.5 minutes or between range of 0.5 minute to 5 minutes while holding the plate just above the melting point of polymer. The optimum pressure temperature is the lowest temperature that yield membrane of completely fused polymer of desirable thickness. If the polymer contains pellets, then result may be improved. To prevent the membrane sticking to the press plate, The polymer usually placed between two sheets of Teflon coated foil or non-waterproof cellophane. Cellophane does not stick to the plate and damped with the water after moduling. It strips is easily from the membrane. So this process illustrated in this figure. We are going to use the polymer pellet to make the membrane. When this polymer pellet pass through this both hot plate at temperature near about that melting point temperature, it make membrane or porous membrane. We can adjust the thickness of this membrane at a different pressure. If we are going to apply high pressure, we will get thin membrane, and if we are going to apply low pressure, we will get thick membrane. So first we are going to use polymer and make it pellet for by crushing it, and this pellet pass through the melt press and converted these pellets into the polymer, and this polymer is go to the storaging chamber. So this is all about the how melt press are used. In melt press there is a cell phone or non-waterproof device are used so that this membrane cannot stick between these two plates. So we are going to use a cell phone or non-waterproof solvent so that this membrane cannot stick over this both plate, and we can easily remove this membrane. So this is all about melt pressing method for membrane synthesis. Now in this lecture we'll discuss about sol-gel peptidation method, in which we are going to use metal oxide, and this metal oxide is converted into the sol by the peptidation, which means converting the particle of solvent into the charged colloid particle. These charged colloid particles are added into the blinder, so it makes sol, and this sol is passed to the filtration or porous membrane support, and we are going to start the gelation process. Gelation process, which means these colloid particles are converted into the solid particle. Now we are going for the sintering process. In sintering process, these colloid particles are merged and convert into the porous membrane. Then talk about the interfacial polymerization process. In interfacial polymerization process, one non-aqueous solution are used and one organic solvent are used. At interface of both these solvent, we are getting the porous membrane. Then talk about the melt pressing, where the two hot plate are used at near about the melting point of the membrane and press at the 5 to 0.5 minute, and applying pressure 2000 to 5000 psi according to thickness of membrane. So this is all about the membrane synthesis process. We will discuss another method of synthesis of membrane in next lecture. So this is all about today's lecture. I am completing my lecture here. Thank you.